Hello everyone, so my name is Tavish and we are going to have this topic of mathematics, that is differentiation. Okay, so let's start. But before going to differentiation, we will go some formulas of differentiation. Okay, so the first formula here I am going to write, and you see what we are going to use. The first one is, that is, if a function y is there, okay, which depends on x, and y is equal to x to the power n. So what will be the differentiation of x to the power n? So if I want to find dy by dx, we can write like this: dy is x to the power of n over dx. Okay, and that is equal to, so the formula is simply, that is, n x to the power n minus 1. Got it? We will do some questions on this. Okay, you see, the first question I am going to take, for example, very simple, that y is equal to x to the power 5. So you have to find dy by dx. Like, what is the differentiation of y with respect to x? Okay. So that will be nothing. You like compare x to the power n, x to the power 5. So n is equal to 5. It means that the formula says n x to the power n minus 1. So it will become 5, because n is 5, x to the power n minus 1, that is 5 minus 1. So it will become 5x to the power 4. Got it? Okay, we will go to the second example here now. And for example, I am taking here x 3x squared. Got it? So don't worry. Whenever we have a constant multiplied, you take it out first. So the dy by dx of this, the differentiation of 3x squared will be 3. You take it out and you put the differentiation here on x squared. Again, it is in the form of x to the power of something. That is x to the power of n, isn't it? So that will be 3 times differentiation of x to the power 2 will be n into, n is 2 here, you can see. So 2 into x to the power n minus 1, that is 2 minus 1, which becomes 3 times 2 times x to the power 1, which is nothing but 3x. Isn't it? Very great. I have some questions here, and so for example, if I will ask you here, what is the, okay, that I will take it as a formula, okay, so that you remember it forever. The second one is, what is the, if y is equal to any constant k, that is a constant, okay? So its differentiation will be, then dy by dx will be, we I'm like, again here I am like differentiating with respect to x, the y is the dependent variable and x is the independent variable here. So that will be what? So always, means like for a constant, the differentiation is always 0. Okay. Why? I will like prove it. I will show you why. For example, I am asking you that y is equal to 5, and you differentiate y now with respect to x. So that you have to like find the differentiation, that is dy by dx, that is of 5. So what is the differentiation of 5? You cannot do this, but we can write 5 as, we can write, like you see, we can write 5 as 5x to the power 0. You might be knowing that x raised to the power 0, or anything raised to the power 0, that is 1. So I can write 5 into 1, that is 5. Huh? Okay, and now 5 is a constant, it will come out. We have to do nothing, but that is the differentiation of x to the power 0. And you use it here, 5 into, so n into n minus 1. So n is 0 multiplied by x to the power n minus 1, that is 0 minus 1. That is nothing but actually 5 into 0, that is 0. Got it. That's why y is equal to k whenever we are saying a constant, that differentiation is always 0. Okay. Remember that thing. And here I will take another example now. I have written something here actually. For example, a third one, that differentiation of root x. Got it? What is that? So that is nothing but, you remember differentiation of root x, you remember that is 1 over 2 root x. How it came, I will tell you. You see, what is the meaning of square root? That x has a power of 1 by 2, isn't it? So it will become like d by dx of, we have to find x to the power of 1 by 2. So what is the n here? What is the n on x? So our formula was what? Dy by dx of like x to the power n was, that was n into x to the power n minus 1. So it will become n is half into, I'm putting a dot, x to the power and minus 1, that is half minus 1. So it will become half x, and 1 by 2 minus 1, that is negative 1 by 2. So negative 1 by 2, I can take it like here at the denominator, I can put it. So this is 1 by 2, x to become 1 by 2 positive now, because I took it in the denominator. Because whenever the exponent is a negative, you can put it in the denominator, okay? So it will become 1 over, and x square is again, x to the power half is again root x. So this will be 2 root x. Got it? Okay, so remember always is the differentiation of root x is 1 over 2 root x. Okay. If someone asks you here sometime that what is the differentiation of x only, can you tell me? Yes. Okay, very great. So differentiation of x is always 1, obviously, whenever y is equal to x given, because dx over dx is gone, and you can use the formula n into x to the power n minus 1. That is actually the first principle of differentiation. Now, if we have y is equal to 1 over x, then what will be the answer? What will be the differentiation with respect to x, dy by dx? Tell me, find it. I am doing it, you also do, huh? Okay. So you see, this becomes like we can write we can write like this: x to the power of negative 1, and we have to find the differentiation of this thing. So again, n is equal to negative 1, so the negative 1 times x to the power n minus 1, so minus 1 minus 1, that is negative 1 x to the power of negative 2. So that becomes how much? That becomes negative x squared, or you can write negative 1 over x squared. Okay, always remember this. Now, similarly, we have some formulas, and those formulas are, for example, like you see, so it was 5, 6, 7. Differentiations of trigonometric like function we have, for example, differentiation of sine x with respect to x. So that is, remember, that is cos x. We will be using these things. And if we have like a differentiation of like y is equal to cos x, okay, then what will be the differentiation? That is negative sine x. And if we have like differentiation of tan x, so that will be sec square x. Okay. If we have differentiation, we want to find, so sin x, cos x, tan x is there. So if we have like, for example, cot x, oh wait, my pen type like has been detached. Wait, okay. So this becomes d by dx of like cot x if I want to find. So that is equal to minus cos x square x. Remember these things always, for always, for ever actually. 11th number, if we want to find the d by dx of sec x, so that is nothing but sec x tan x. And if we have d by dx of, we'll be like solving using, whenever we'll be solving questions, then we will use these things. Okay, so again I will come to that. Whenever I solve questions for cosec x, that will be minus cosec x cot x. Here you see a trick, like something you can observe, that anyone which has like, see, cos is with starts with c, cot starts with c, and cosec starts with c, they all are negative. Negative sin x, negative cosec square x, and like cosec x, that is negative cosec x tan x, cot x, sorry, isn't it? So have that in mind. And apart from this, there are some like inverse functions also. So I'm not going to that. So whenever we will come to that chapter, we will be solving like what is the differentiation of sine inverse x, tan inverse x. Okay, I will tell you three. The first three, that differentiation of sine inverse x with respect to x. Okay, so that becomes nothing but 1 over square root of 1 minus x square. Similarly, if we have here in 14 number differentiation of like cos inverse x, so that becomes nothing but negative 1 will be here, and 1 minus x square. But if someone asks you that what is the differentiation of tan inverse x, Okay, so that will be nothing but 1 over 1 plus x squared. So remember these things, have this in mind. Now, I will change the color of my pen for this one, 16th one. Have this also in mind, you'll be using it. dy dx, whenever you have to find the differentiation of log x, okay? So that will be nothing but 1 over x. So have this into, and one more thing at the last, and there are many actually, means you can write, wait, let me do this here. Okay. So yeah, so differentiation of, if you want to find the differentiation of e to the power x, remember e to the power x is something, whenever you differentiate or integrate, you will get the same thing. So that is e to the power x. Got it? So remember things up to here. These are nothing. Let me go to the previous pages. You see, first we started with this, like y is equal to x to the power n. So x to the power n, that has the differentiation as n times of x to the power n minus 1, and then constant has 0. The differentiation of constant with respect to anything, that is 0, and root x is 1 over 2 root x, so that is actually an implementation. Now what I will do, I will tell you some rules, actually rules of differentiation. Okay, so here come to the new page, and here I will tell you what I will tell you, rules of differentiation. So what are the rules? There are many rules. Some are very much important. One rule says that if you have like two, three, or four, like more than like one function, okay, and they are like added or getting subtracted, so you have to separately differentiate each term. Okay, so for example, if I can write here, if I'm writing here that you have to find the differentiation of, there is a function, and that is u, for example u, okay, and plus b. So you have to do nothing. You will differentiate u with respect to x, and you will respect v with respect to x. Got it? Separately you will make. If it is plus, you will put plus. If it is negative, you will put negative. So that is very simple. That is nothing actually. I will take an example here for this even. Okay. So see the example. I have like written that there is a function, that is y is equal to x squared minus sine x plus tan x. Now, this is like an application of the formulas which I wrote earlier. So you might remember these things even, okay? Okay, okay. See, we have to find dy by dx. So this means that nothing. How can we find? There are three terms that are getting added or subtracted, okay? So what we will be doing here, we will be like differentiating each of them separately. So this is the first rule actually, that we will separately be doing things. dy by dx of sine x here, and plus dy by dx of tan x. Okay. Okay. Now this is your term now. Term. Okay. That what is the differentiation of x squared? So this is in the form of x to the power n, and x to the power n was having the differentiation as what? N times of x to the power n minus 1. Isn't it? Yes. So what is our here, that is what we have here. We have x squared, so it will become 2 into x to the power 2 minus 1, which is 2x. So this becomes 2x minus, what is the differentiation of sine x? Tell me. That is cos x. Huh? Very good. And what is the difference of tan x? That is sec square x. You see, very simple. So you got the differentiation of this y. You got the dy by dx. Got it? This is the answer actually. Let me see if I have another question. Okay. We have like another rule here. The another rule says that that is nothing but the product rule. Okay. See, what I will do here, what I will do for this product rule, I will go to a new page. Let me start a new page here. Yes. So the product rule. Now you have like two functions. Okay. And they are getting multiplied with each other. So how will you differentiate them? For example, you have to find the differentiation of dy by dx of two functions, u multiplied by v. They both are the like functions of x. Like u is a function of x, and v is also a function of x. They both depend on x. So how can you find that? So there is a rule. It says that whenever two functions are like getting multiplied to each other, so you will say this as the first and this is the second. So you will say first into, or I will write in the form of u and v. Let it be like, let it be in the form of u and v. So u into differentiation of v with respect to x plus v into differentiation of u over, not over, nothing. This is like the differentiation, isn't it? Let's take an example here, okay? Then you will get it. For example, I had written a question once, yes, that there is a function y which is x squared dot cos x. They are getting multiplied. X square is a function of x, cos x is the function of x, and they both are getting multiplied. And we have a like function y. How can we like find the differentiation of y with respect to x, d by dx? So what you will do, you will consider this one as u, this one as v. So the formula says that u multiplied by u means x squared multiplied by differentiation. I will write here differentiation of v. V is what? Cos x. The another one plus the another one means now v into, so v is cos x multiplied by differentiation of the first one which is x squared. Done, huh? Done. So x squared multiplied by, what is the differentiation of cos x? I told you just now. Tell me. That is negative. Yes, very great, huh? That is what I am writing. What I am writing. That is negative sine x. So we will write here negative sine x. And this negative will go out. And plus cos x multiplied by differentiation of x squared with respect to x is how much? Can any one of you tell me? Yes, that is 2x, huh? Okay, nice. So this becomes what finally? Like x squared sine x, my negative, in plus 2x cos x. This is the answer. This is the answer. So what the product rule says, it says that if you have two functions, so first into differentiation of the second plus second into differentiation of the first. And this is the product rule. So whenever two functions are getting multiplied with each other, then how will you find the like differentiation of them? Okay. Like see, if they were to be added, for example, A and B were to, they are two functions, they were to be added, then simply you can find this differentiation of A and B and you add them. Even if subtraction, you subtract them. But in multiplication, you have to use this formula, this rule, that first into differentiation of second plus second into differentiation of first. Got it? Now, similarly, we have a rule and we call it as quotient rule. The name says that quotient rule is nothing but whenever two functions are getting divided. So I will write like this, that y is equal to u over v, and they both are functions. U is a function of x, and v is also a function of x. How can we do that? So we have a rule here, dy by dx will be, for this will be like the denominator multiplied by differentiation of the numerator. Got it? Plus, sorry, not plus. That is minus the numerator multiplied by the differentiation of the denominator over denominator squared. This is the rule. This is the formula here. How to find whenever two functions are getting divided. Got it? Okay. See, I will take an example. It will be more clear to you. Okay, so I had a question here that is very simple question I had taken, that y is equal to x squared over sine x. Okay, you can see here, x squared is the function of x, sine x is the function of x. They are getting divided. So what I will do here, we have to find dy by dx. So what we will do, differentiation of y with respect to x, we have to find. So this is the denominator, this is the denominator, this is the numerator. So v means denominator. So we'll write the denominator first, multiplied by differentiation of x square. Means I will write here d by dx of the numerator, that is x square is the numerator, minus here u is the denominator. Sorry, the u is the numerator. So that is x squared and differentiation of the denominator. So d by dx of sin x, because sin x is the denominator, over we have v squared, denominator is squared. So denominator is squared will be what? That is sine squared x. isn't it? Now solve the things on the top and you will get the answer. This is very simple. Nothing is here. Sine x and x squared is 2x minus x squared, and sine x is cos x, so it will become uh, x squared cos x, isn't it? Differentiation of sine x is cos x, and differentiation of x squared 2x over sine square x. So, like, this is the answer. So, keep it up to here. This is the answer. Got it? Okay. So, what I was saying is that now I will take some questions. I had prepared some questions. Let me find those questions here first, and then I will tell you. And using this, quotient rule, we will find one more rule. We will like find that is nothing but the reciprocal rule. So, what is reciprocal rule? If you can understand that, let me change the color to yellow something now. Reciprocal rule. See, this is very simple and it will make our like questions, our like problems very much simple if we will know this rule, that whenever you have something, a function in the reciprocal, like a function of x like this is our y. Now what will you do? So for finding for such a function, the dy by dx will be nothing. For this function, what you do, put negative the derivation of x on the numerator and square of the function. Square it. Confused? Getting confused? But this is nothing. This is actually the quotient rule. I'm telling you. I will prove it by one thing actually. You see, I'm taking example and I will do that question by reciprocal rule even and by the quotient rule even. Okay. So the question is, for example, our y is 1 over x squared. You see here, 1 over something. So using this reciprocal rule, what it was saying, reciprocal rule says that the function is x squared. So take the negative and differentiation of x squared. See, f dash means differentiation. So d by dx of x squared. And at the denominator, you put the square of that thing, of that function. That is x squared is the function given here. So put square of this function, that is x squared. So how much you will get here? The differentiation of x squared is 2x, so negative 2x over x to the power 4. So x and x is cancelled from the numerator and the denominator. So you'll get negative 2 over x cubed. Isn't it? Isn't it? Yes, you will say yes. But the same question, if I'm doing the same question with quotient rule. So y is equal to 1 over x squared. Our quotient rule said that I'm doing with quotient rule here. See, I'm writing here by quotient rule. I am like this is our denominator. So you will write denominator into differentiation of the numerator minus numerator into differentiation of the denominator over denominator squared. So x squared, again I square on this. So this will become x squared. Differentiation of 1 will be what? Any one of you, please tell me. 1 is a constant and constant's differentiation is 0 always. So this is 0 minus differentiation of x squared, that is 2x. 0 minus 2x over x squared, and again I square on that. So that will be x to the power 4. Finally, we got 2 over x cube. So nothing but remember this rule, that whenever you have 1 over something, for example, I'm taking another example here, that y is equal to x squared plus 7x plus 3. Now, sorry, this is not the question. This is the y is equal to, see, that will be 1 over x squared plus 7x plus 3. Reciprocal. It is a reciprocal function, you can see. Okay. So how can we find dy by dx for this using the reciprocal rule? So it says that put the negative of the negative and the differentiation of the denominator of the function. So that is differentiation of the function over the function squared, isn't it? So like it will become negative and differentiation of, I will write here differentiation like this, d by dx of x squared plus 7x plus 3, I will write here. Okay, divided by the functions squared. So that is x squared plus 7x plus 3, then whole square on this. Okay, now differentiation of this thing will be what? That is negative here, that is upside down. X square differentiation is that is 2x, n plus this is 7. So this is all over. This will be x squared plus 7x plus 3, isn't it? And we have a square on the whole. So what you do, this is the answer actually. So you stop here, but you got the differentiation using that reciprocal rule. Got it here? So what I was saying that we will be like solving more and more question. I will take a question, but for that, see my next video. Be with me and be connected. So my name is Tavish and I was your math tutor for today here. So how was the session? Let me know that.